Good morning. Today we are going to see the next method, that is moment area method. So it have two theorems. So first theorem of moment area method. The first moment area theorem is that the changes in the slope of a beam between 2 points is equal to the area under the curvature diagram between these 2 points. Curvature diagram is equal to MEI diagram. So nothing but slope is equal to dy by dx, that is equal to theta, which is nothing but area divided by EI, where A is the area under the bending moment diagram between the 2 points selected. EI is flexural rigidity. Then second theorem. The second theorem is that the vertical distance between a reference tangent line, that is tangent at one point of the beam, and B, the deflected shape of the beam at another point, is equal to the moment of the area under the curvature diagram between 2 points, with the moment of the area calculated relative to the point on the deflected shape. Deflection is equal to A x bar by EI, where x bar is the distance between CG of the area and point at which deflection is calculated. So these are the two definitions. Only based on these two we are going to see this method. So certain points to remember before starting this method. Already you know about some of the shapes, their area and their CG distance. Again we are going to see some basic shapes. So right angle triangle, so area is half into base into height. Here x, this is x1, that is from the base or from the height. This is x2, distance of CG from the vertex. So x1 is 1 by 3 of B, and x2 is 2 by 3 of B. Next shape is rectangle, B into D area, and then x1 will be equal to x2, that is equal to B by 2. Then this is a parabolic curve. You have seen this diagram in the bending moment and shear force diagram. So we have to calculate the area for this also. Area is 1 by 3 B into H, and x1 distance is 1 by 4 of B, and x2 is 3 by 4 of B. Then this shape is also seen in the bending moment diagram of simply supported beam. This is a UDL beam. This is UDL beam. Here 2 by 3 into base into height. Then x1 is B by 2, x2 is B by 2, half the distance. Then a triangle with different base lengths, that is A and B, that is this peak value is at a distance of A. So this type of triangle will come in the simply supported with A distance point load. Here area is equal to half 1 by 2 into H into A plus B. X bar is B by 3 plus 2 by 3 into A, and x2 is A by 3 plus 2 by 3 B. Here A should be less than B. Then again, this is a very important note, only cantilever beam is computed in this method, because simply supported is much difficult in this method. It can be used by using Michaelis method or conjugate beam method. So only cantilever is very much easier in this method. So basic procedure. Let's see with procedure. Step 1, draw the bending moment diagram. So for any beam, first you have to draw the bending moment diagram. Then choose the point at which the slope or deflection need to be calculated and find area of the bending moment diagram between the points from the fixed point to the point of x bar, which means that you have to choose 2 points between the beam, and then between the 2 points you have to calculate the area of the bending moment diagram, and you have to calculate the distance between you have to calculate the CG distance, that is x bar. Then apply the first theorem of moment area method, which is nothing but slope is equal to A by EI. Second theorem, deflection is equal to ax bar by ei. Here again note, units are very important in conversion, because you will see in the problem why conversions are very important here. Then very first simple example, a cantilever beam with a point load at the free end. So this is a cantilever beam with the point load W and a length of L, and it has E value and I value constant throughout AB. So here you can see that for step 1 we have to draw the bending moment diagram. So bending moment at B is 0, and bending moment at A point is W into L, force into perpendicular distance. So we are choosing what they are asked is we have to find the deflection and slope at the free end. So what are the point you have to choose? Always one point is a fixed support, another point is the point at which we are going to calculate deflection or the slope. So here at B we are going to calculate, so the distance is between A and B. So you have to choose the area between A and B. So here area is half into base into height, as it is a triangle, so it will be equal to minus W L square by 2. Then CG distance. So what the CG point is, the we have to calculate the x bar. X bar is nothing but the CG point to the point at which we are going to calculate the deflection. It is the distance x bar. So here from B we have to see the horizontal distance between the CG and B. CG and B, it is nothing but 2/3 of L. In the previous in this case I have discussed what is the distance x bar values. So here it is 2/3 L. Then step 3, slope, or it is dy by dx, or it is theta, which is nothing but A by EA. So area here is WL square by 2, WL square by 2 divided by EA. So this is the value of slope. And for deflection, Ax bar by Ei, it will be equal to WL square by 2 Ei into x bar 2/3 into L. So totally minus WL cube by 3Ei. So next, cantilever beam with point load at a distance A. That is, this point load is at a distance of A, and the remaining portion is L minus A. So this is point A, this is point B, and this is point C. Now we are going to calculate the slope and deflection at point B and also at point C. So first step, we are going to calculate the deflection and slope at point B. So for that, A and B, the points are A and B. So this is the bending moment diagram. You can see that at B it is 0, and at C it is 0, and at A it is W into A. So here we have to calculate 2x distance, that is 1 for y2 distance, means we are going to calculate the deflection at B and at C. For B, the distance is from the CG point to the B point. So next it is from CG point to the C point, that is x2. So x1 is nothing but, you can see that first we have to calculate the area of the bending moment diagram between A and B. So area is half into A into WA, it is WA square by 2. Then x1 bar is nothing but 2/3 of A. Here from this to this point, that is C point, it is 2/3 of A. Then L minus A plus L minus A. So it is totally L minus A by 3. Then step 3 is to find the slope. It is area by EI. Area is WA square by 2, and it is by EI. Then deflection. Deflection is Ax bar by EI. So A by EI, WA square by 2 EI. Then x bar is L minus A by 3. So after simplifying, it is minus WA square by 6 EA into 3L minus A. Then for slope and deflection at C, for to find the slope and deflection at C, now the area is between A and C. You can see that the area is between A and the C, only A and C. So here area is WA square by 2, and x bar is only 2/3 of A. You can see that the distance between CG and the C point is x. 2, that is equal to 2 by 3 of a, and slope is equal to a by ei, which is wa square by 2ei. Then deflection is equal to wa square by 2ei into x bar. So x bar is 2 by 3 of a, and it is equal to minus wa cube by 3ei. So this is the final formula. So next example, a cantilever with a UDL throughout the length, that is from A to B. The total length is L and the intensity is small w. So step 1, bending moment diagram. You can see that it is a parabolic curve. So this shape have an area of 1 by 3 base into height, and x bar is and actually I have made a mistake here. The x bar is 1 by 3 by 4 of L. X bar is 3 by 4 of L. So here slope is a by ei, area is wl square by 6ei, and here x bar is 3 by 4 of L. Kindly change it. X bar is 3 by 4 of L. So here substituting 3 by 4, you will get WL cube by 8EA, not 9EA, it is WL cube by 8EA. This is deflection. So with this I am going to conclude this video. I will teach the numerical problem in the next video. Thank you.